Hey there everybody, Bob Kraft here for Advanced Technology Solutions. Today, I'll be talking about what it takes to be successful with your condition monitoring and evaluation program. This discussion builds from concepts I presented in previous vidtutorials that we've already posted at ats-inc.org/blog. We know that condition monitoring and evaluation is primarily a planning tool used to help us identify situations going on in our machinery and systems that, if not corrected, would lead to functional failure and loss of valuable productivity. We use condition monitoring data to detect, diagnose, and prognosticate on what's going on in our machines and systems, kind of like your physician does when you go in for a physical exam. The detection aspect identifies the fact that something's going on that's not entirely right. The diagnosis phase is where we interpret the data to get an understanding of what's actually happening, and the prognosis stage is where we apply our understanding to determine what needs to be done to address the issue and when we should do it. So the real question is, what are the key elements required for a successful program? Don't worry, I'm not going to stand here and tell you that you need this specific technology or that specific technology to be successful. In my experience, knowledge, and not any specific particular technology, is what makes a program successful. The most important knowledge element is a thorough understanding of the machinery and systems, literally at the gut level. You need to understand your machinery in terms of the internal components that it's made of and how they're put together, how it's built and installed, how it's supposed to run, and how it relates to the whole production process. You need to be like a superhero with X-ray vision, not necessarily able to leap tall buildings, but able to look at a machine and visualize its internal components. And absolutely, you need to be able to understand what they each do, why they're there, and how they interact with the rest of the machine or system. If you have this gut-level understanding of the machine, then I promise you that you already know intuitively both how it's likely to fail in service and how those failure mechanisms will show themselves to us when they're in progress. At ATS, all of our team members who evaluate your data have extensive experience managing, maintaining, and monitoring machinery. We only hire folks who already have this requisite gut-level understanding of machines. Remember, functional failure is a process. It only becomes an event based on how we react, or not, to the situation. So with this understanding, we're in the best position to go to the next step, and that is methods. Having and using the right technologies and skills means using the right technology or technologies that help us recognize that one or more failure mechanisms are in progress, or that some irreversible damage has already started that requires our attention. Data needs to be collected frequently enough that we can assure ourselves that we'll be able to see the problem developing with sufficient time to react to it. Data needs to either be collected under consistent operating conditions, or we need the ability to record the machine operating state with the data so that we'll always know what was going on in the machine when the data was collected. We need to be able to compartmentalize the data so that we can differentiate between what is normal and what's not normal for each operating mode, speed, direction, load, or whatever that the machine goes through during its normal operating life. Think about your car for a minute. You know what your car sounds like when you back out of your driveway. You also know what your car sounds like when you're accelerating onto the interstate. Both sounds are different, but normal for what the car is doing at the time. If it sounded like accelerating to highway speed when pulling out of your driveway, that would be a clue that something's not right, unless, of course, you're hearing it from outside the car and your teenager's the one who's backing it out. Also, you need the data collection to be thorough and able to target as many of the primary failure mechanisms as practical. What we do with the data is also important. Evaluating condition data is more change analysis than anything else. We're trying to understand what's different this time compared to the last time we looked at the data. We need to understand what that data is trying to tell us. Really, your data does talk to you. You just need to be tuned in to listen to it. The final step is to be sure to enter all the findings and recommendations into the work management system so that the corrective action can be properly prioritized, planned, scheduled, and have the appropriate resources allocated to it. I've seen more cases than I'd care to count where problems were identified, but corrective action wasn't taken in time, and the machine failed, primarily because of a breakdown in the communication handoff. No real surprises there. When it comes to deciding how to apply our chosen technologies, we need to think back to the concepts we've discussed previously. Specifically, the anticipated time from problem detection to either damage or functional failure, the concepts we get from the extended PF curve, and we need to consider the cost consequences of having the functional failure unexpectedly. Now, there are no absolutes in what I'm about to describe. Your unique situation must be taken into consideration. That said, in general, if it takes a relatively long time for a problem to progress from when it is first detectable and/or the cost consequences of losing the machine or system are relatively low, then it's probably a good candidate for periodic monitoring using handheld walk-around instruments, where data is collected on approximately a monthly basis in general. This applies primarily to low cost consequence, long degradation development machines. As machines get higher in value in terms of cost consequences or criticality to the operation, and/or the time from first indication to failure is on the order of a couple of months to a couple of weeks, then battery-powered wireless sensor systems that collect data at intervals as low as every hour or every few hours would most likely be sufficient. Higher value machines, on the other hand, in terms of the cost consequences of their loss and criticality to production, or they progress to failure in a week or less, should be monitored with permanently mounted sensors wired to permanently powered instruments that are capable of collecting data on the order of every hour to as quickly as every minute. Of course, all this data needs to be sent to a central software or dedicated remote monitoring center for evaluation so that timely recommendations can be made. This is why at ATS, we support all types of data collection for multiple technologies. Our goal is to help you get the most value from your investment in condition monitoring, and we look at every sensor on every machine, every workday, to provide recommended solutions before problems have a chance to develop out of control. That's it for today. Stay safe out there. And please, make sure that when you go home at the end of your shift, you get there with all your body parts intact. Bye for now.